All right, thank you. So the title of my presentation this morning is using large language models for data analysis. I was asked to present something on AI and research and related to large language models and how we could use these different language models in different areas of research. If you don't mind, I'm just going to put off my camera. It just makes the presentation easier. So just quickly, something about myself. My name is Wouter Klapwijk. I'm, as Kirchner said, the Director for Information Technology Services in the library, and within that portfolio, we take care of library ICT matters, all matters related to networks, computers in the different libraries. And we have also the makerspace and the new immersive technology lab reporting to my division. Okay, so I need to position my talk this morning on large language models for data analysis within the library's research support services value chain. And what I mean by that is if we look at all the different presentations in this year's research week, those presentations that we already had yesterday and the day before, and those we're having later today and tomorrow, they touch on different library support services within the research lifecycle. We had presentations on how to do literature reviews. We're having one coming up on proper data management practices for research. We've had one yesterday afternoon on using Atlas TI for qualitative data and doing data analysis. We had presentations on writing, managing references, and managing your thesis and dissertations, optimizing the visibility, and measuring author impact. If those presentations haven't been presented yet, they start to come today and tomorrow as well. So my challenge was to present how we can use large language models for data analysis within these topics which we're covering within in this research week. So I decided what I'll do is I'll expand on the data analysis support service we provide to our researchers and try and provide a bit of guidance on using large language models for data analysis. And I'll do it through two example scenarios. The one is to use a large language model for low dimensional data, and the other is to use an artificial neural network for high dimensional data. But I should just qualify that the majority of the presentation is looking out for pitfalls when using a large language model for low dimensional data analysis. And then I'll just briefly touch on in what circumstances would you not use a large language model for high dimensional data, and how to get started with the artificial neural network. But before I do so, I should, let me just, before I do so, just say something about the dimensionality of data when using large language models for data analysis. High dimensional data is usually characterized by a high number of features or variables in a data set, as opposed to the number of observations within that data set. So if you have, for example, a data set which only contains 100 observations or 100 entries or rows or items as such, but each of those entries exist of 1,000 variables, then that would be regarded as very high dimensional data. That's usually denoted as the features over observations problem, or P being much greater than N. And although large language models are increasingly suited for high dimensional data analysis, their effectiveness really depends on the type of data and the specific task you want to use it for. So the reason I'm highlighting it here is because if you want to jump away and start using large language models for data analysis, just be cognizant of the fact that the type of data you have and which you would like to analyze depends on how effective you can use a large language model for that. So artificial neural networks are indeed the foundation of large language models, with just much more parameters and observations encoded as tokens. But for specific structured and resource constrained tasks, it's better to use an artificial neural network. Okay, that sounds not very technical, but we'll get to explaining that step by step as we go along. Before I do that, first, I should just quickly use this moment to do a bit of marketing for our new immersive technology lab, which we launched in January. And the reason why I'm doing so is because it's very fitting to the topic of data analysis. Within this lab, we don't just do data visualization, but we also do data processing to analyze data. An example of that is we had a research on forestry science in the lab last week, where we processed a forestry data set using the GPU in our lab, which that processing usually takes up to 8 hours on his own equipment, and he managed to do it in 47 minutes within the lab. And added to that, he could visualize the full spectrum of the data he analyzed within the immersive space. It's a 50 square meters of display we have in the lab. So this is a new service we like to also just keep on communicating to our users about, which you can use for data analysis and visualization. So there's a lot of application categories within the lab. You can work on creating presentations, creating videos, displaying videos in 360 degrees. We can display any web browser-based content in an immersive space, in the immersive space or in immersive environments. This is 270-degree panoramic view you have in the space with aspect ratio of 22 by 9. That's basically 9,000 by 1,200 pixels. So it's a large visualization space. It's open and available for all our students across all disciplines to use. You can just book your slot in the space, and you'll get assistance with doing programming in Unity and Unreal. We don't really give that assistance ourselves, but we can give an advisory experience. We can give you a referral service in order to assist you in doing that sort of programming. And then you can do a lot of the data analysis in that as well. Okay, but having said that, let's move on to using the large language model for low dimensional data analysis. So I want to sketch a scenario, because I'm not using my own data here, but I'm using data which is publicly available, and usually these publicly available data sets being used for these typical type of analysis within a large language model. The scenario is you're collecting research data with a survey or questionnaire. For example, you are in marketing research and you're studying what makes a consumer request for a free product successful. Like I said, I got this from Reddit, where they're sharing all this these experiences and data sets. And this one is called the Random Acts of Pizza. And basically, you can get pizza for free. And this marketing research exercise measures what is your reaction when you get the pizza for free. And they collected a lot of samples, and now you need to analyze that samples in order to determine sort of the sentiment analysis of the people when they get this free pizza. So this data has a small number of variables, only a couple of columns, and it's got about 100,000 entries, of which we just use about 100 for sample data. So it's low dimensional data. But what is important is when you will do your data analysis on this sample, you would like to publish the methods and the results of your analysis, and then you like to make those findings reproducible for others, and also later for yourself using a large language model. And that's where the trick comes in. So we set out basically to collect the data, and there are AI-enabled tools which helps you also create surveys, which will give the respondent to the survey a more realistic and an interactive experience, other than the standard tools available. For example, at Stellenbosch University, you can use Claude Code to create an AI-powered chatbot that you can embed directly, for example, in Qualtrics, which is a survey-based system. Or you can use the Research Chat AI platform to create a customizable chatbot for collecting data. So you set out to collect your data, and now we have this data, which, like I said, it's a data set containing answers whether you received your free pizza. This data set you can download from Kaggle, and basically it includes a request narrative and an outcome. Did you receive a pizza? And your encoding task is, your analysis task is to classify each request as positive, negative, or a unclear appeal. And the method you would like to use to do this is you would like to use natural language processing in ChatGPT to instruct it to do this classification for you, because it's a simple data set and a relatively simple analysis. So why would you use Atlas TI or another project to do this if you can very easily do it with ChatGPT? So you upload the data into ChatGPT or into Claude, and I'll be using ChatGPT as an example. I'm not going to demonstrate anything. Everything is within the slides, and I will just talk through the process. You write a prompt, upload the spreadsheet, ask it to code all the posts, all the observations, or all the answers to your survey to determine the appeal type. And the results looks good for you. So you ask yourself, okay, but what's the problem? Isn't a large language model like ChatGPT adequate for doing this data analysis? So actually the answer to that is ChatGPT is not adequate, but a large language model can be adequate if you use it in the correct way. So to talk through this, we need to differentiate between a large language model and ChatGPT for when doing data analysis. A large language model, as we have all heard already endlessly, is basically a next token predictor. Given the tokens it has so far, or seen so far with the input prompt you give it, it predicts the next word, and as such it predicts the next word. Okay, but the problem for this within the context of data analysis, it's a probabilistic model. It's not deterministic, so nothing is determined beforehand in a fixed way. The same input you give it in a day or two from now can produce a different result than the result you get when you use it today. And obviously there's a temperature control which determines how much variation it can produce in the results, but you don't have full control over those settings. So it's not really optimized for factual accuracy. It's only optimized to produce plausible sounding continuations of the next tokens, as the next token principle. ChatGPT, as such, is not the large language model. Okay, the large language model is the raw model which has no memory, no tools, and no guardrails. It's a model existing of a number of tokens, and it has got no guardrails on it. It's got no interface on it. It's a foundation model optimized for language purposes. And you can have foundation models optimized for image processing as well. In this example of research analysis we're doing here, we're working with text. So it's for language optimization. But what ChatGPT does, it wraps this large language model in a system. So what it does, it adds file uploaders to your interface window, a code interpreter in the back end. a web search function which it calls whenever it needs to, when it does not have the latest data you asking for it, when you refer to, for example, date stamps. In data that is date stamped for more recent data sets which have not yet been, the large language models have not been trained on. It will call the web search function. It's got a memory in terms of your previous prompts you gave it, and it's got a number of safety filters built into this. So this actually is problematic in a way when you upload a spreadsheet into with your observational results into ChatGPT and ask it to analyze that as such. So as a better way to demonstrate how ChatGPT actually is put together, I've copied this very nice diagram from Simon Blanchard at Georgetown University, where in his paper he does a very good description of it. Your large language model within the whole ChatGPT system is only one box, and then that is wrapped by a number of additional components: your Chat UI, which you interface with in your browser, your document processor, which you use to upload your document, and that goes and analyzes your document if you give it the permission to include that document contents in its training model or not. And then a number of services the large language model will call if it needs to do so. For example, computational tools. If it needs to write a piece of Python code to present you with an output, then it calls it a Python interpreter. That Python interpreter is not part of the language model. It calls other data processes. It will go into retrieval augmented mode in order to retrieve data directly from the internet or from a RAG database or a knowledge graph, where you have much more factual or symbolic data pre-prepared, which it wants to call upon. And it can go into multimodal mode and call the image generator, depending on what you request through the chat interface. Now, this causes problems, and this is all very good and nice, and this is a very powerful tool to have, but this causes problems with reproducible research. Because if you prompt the model today with your data set and you give it instructions how you want the model to analyze your data, it will be calling upon a number of different resources to do so, and many of them it will be dependent on many of them completely in order to give you the results, and not on the semantics within the large language model. For example, in our case, what happened is I took the marketing results of this free pizza survey. I uploaded it as a spreadsheet into ChatGPT, and it routes it through its code interpreter, which is a Python environment. And that is used to write a keyword matching function, and it's on your spreadsheet file. And unless you save that generated Python script, you cannot replicate that exact procedure to analyze that data in future. So if you citing within your published work how you've used ChatGPT to analyze your data, nobody else will be able to replicate that exactly to see the accuracy of your analysis. Okay, because the Python script used will perhaps generate a different code base on a subsequent rerun. So fundamentally what happened is, in our example, ChatGPT took your data, it wrote a Python script, and it called a dictionary called LWIC. It's a general purpose language dictionary for sentiment analysis. And within that dictionary, if you go and look at the code, it included the data dictionary within its code, and it analyzed all the responses to the survey in order to determine a positive, a negative, or neutral appeal to receiving free pizza. And it did not depend on the semantics of the large language model itself in order to use that richness in the model to analyze data for this determination of the appeal type. So likewise, if you were to go and you would rather just go and copy all your responses to the survey as plain text, then you put it into the prompt window, because you can put a lot of data into the prompt window depending on the size of the prompt window of the ChatGPT version or Claude version you're using. Then you have even a greater problem, because now it's actually using the large language model itself, not really calling the code interpreter, but it's using that full data set in context, and it's learning from the first response right through to your last response in an iterative way. So your later responses of your data, which has been processed, is being influenced by your early responses. So you're actually giving the large language model too much context to determine a unique appeal type for, say, response number 98. Because I'm writing response number 100, because the preceding 99 responses basically added so much context to the response of 100 that the large language model has used that to train itself in order to determine the response for entry 100. So if you rerun that prompt again, you'll get different results again. So the problem with this approach is your research is the analysis of your research is irreproducible for others, or you're giving it too much context. So the solution around this, if you want to use a large language model per se to analyze your data, is to use the application programming interface it provides for you, and not the chat interface. Now, by using the application programming interface, or the API, you can call the large language model directly, bypassing the complete chat wrapper, bypassing the code interpreters, and all the document processing functionality built into the complete ChatGPT interface and wrapper. And you can utilize the richness of the large language model directly in order to determine your appeal type, in this case, for your different responses to your research, to your questionnaire. And you do this by prompting the large language model one response at a time. So with every pass of your code, calling the large language model through the API, it only has the context of that response type, that response entry. And it's not being influenced by the preceding, for example, 99 responses, which you are also feeding the model if you were to do it directly into the context window, or directly into the prompt. An important thing about doing this is, if you would like to cite how you produce the analysis in your paper, then you can declare what your prompt was for passing every response type to the large language model. You can declare what your GPT model was, because GPT models get locked, and then they don't receive any further updates. And OpenAI, for example, typically supports the models for a minimum life cycle before they deprecate them. And I'll get to in a moment further what you can all declare in your publication, how you analyze your research data to make it for somebody more reproducible. Okay, so in order to do this, you can just simply go and get your API key from OpenAI, the company behind ChatGPT and the chat LLMs. There's a small cost associated to it, but the key is unique to you, and you can go and write a reproducible script of your own using basically Claude-generated code. In this case, there's no danger in using Claude in order to write a piece of code in order to just call an API and feed it with the next item in your database or in your data set. In order for the large language model to use the prompt which is you send with this API call and analyze the appeal type in this case for the response to whether you are happy or not to receive free pizza. So essentially, what you can do is you can reference the locked model version of your large language model in your research. You can specify in your research publication your actual prompt you send the large language model. You don't have to share your API key, obviously, because then everybody else can use your API key as well. But you obviously indicate that an API key can be received or generated from the OpenAI website. And you specify the parameters you sent your API call. So the temperature parameters and the max tokens you use to call the large language model. So what the result you get is one independent API call per observation. And that ends up being verifiable and reproducible results for somebody else to use in future in order to reproduce your research analysis or your data analysis, but also for you to reproduce it if you had to. And you use in the process the richness of the large language model to analyze your data, and not a Python script, for example, which calls a data dictionary. So not everything you feed into the ChatGPT windows actually uses the large language model in order to give you a output. In our case, when I uploaded the file to ChatGPT and wrote the prompt to analyze it, the only thing it used the large language model for was to create the Python script. And then it used that Python script to call a data dictionary and use a data dictionary, an external data dictionary, to analyze my data. It did not use the natural language capabilities of the large language model to do so. So essentially, what I'm trying to demonstrate by this is that if you want to use a large language model to analyze data, then you need to call it in the correct way, use it in the correct way to ensure that every entry of your, for example, your survey data gets analyzed separately from the other entries, and every one is reproducible in future by not passing your data for analysis through the ChatGPT wrapper. Okay, so that really is a good method to use a large language model for low-dimensional data. Now, if your the dimensions of your data starts to increase and moving towards high-dimensional data, you might find it very difficult to pass a data set into to the large language model with an API to analyze, for example, 1,000 variables for every observation in the data set. The large language models are becoming increasingly more effective to do this because they basically translate this data you're feeding into it into like a vector space, as a technical term, in order to tokenize basically your input and then use its own large language model capabilities to analyze that high-dimensional data. But there are cases where essentially you would not like to rely on a large language model to do this, but we would like to have more control over how AI can analyze the data for you. And I should just reiterate here once again that a large language model is built on an artificial neural network. That's the foundation of what it is. So obviously it translates what you give it into a neural design or neural format. But essentially your choice in statistical analysis, if you want to use AI, really depends on the dimensionality of your data. And high-dimensional data can be found in both the natural and the social sciences. It's not just something you find in the natural sciences. For example, biological data is a good example of a many-dimensional data. Metagenomics is not high-dimensional data. It's big data, but it's not high-dimensional data. Whereas in social sciences, you could use, for example, a data set which contains a digital trace from a social media platform, like, for example, tweets on what's it called, X these days, Twitter. And you want to do sentiment analysis on those tweets. And that would be high-dimensional data that you would use for example, social sciences, computational analysis. So I'm not really an expert on artificial neural networks, but what I thought I'd just very briefly describe here in a few slides is what is meant with high-dimensional data within an artificial neural network, and why you wouldn't necessarily call upon a large language model to analyze this data. This is biological data. And I just would like to make it clear there, don't use ChatGPT for that. Sorry, that's one slide too many. So this is many dimensional data, for example, for single cell biology. I would imagine I got this from Lund University. This is in partnership with Stellenbosch University and a number of projects from a data scientist over there with whom I'm in regular communication, as an example. So it contains a number of observations with a number of features. And what we find here is that the P is the features, or the P as such, is much greater than the N as the observations. So you need to use a graph network in order to plot this data and to analyze it. So essentially what you would do is you would build an artificial neural network from scratch in order to do that. And this sounds very complicated, but I just would like to skip 2 slides forward to show you. This is my last slide, by the way. You can run just a simple Python script in order to do that. Just going to back again. So basically what you have here is your data array. You've got 2 variables here, or 2 nodes, x1 and x2, and that's sort of mapped out over the hyperplane. And those nodes values are your input nodes into your neural network, and they need to produce a ground truth outcome. So this is the ground truth. You know what the artificial neural network should provide you through a process of forward propagation. And this is what I'm trying to achieve by setting certain weights. You start off by giving it arbitrary weights, and then through a process of gradient descent, or actually back propagation, you are able to then go and adjust those weights through different iterations in order to get closer, to adjust the weights in order to get your ground truth. Now, that's the overall theory behind it, and obviously there's a lot of algebra and calculus behind this. But essentially, what I'm trying to explain by this is this is a better method in AI for analyzing high-dimensional data than what you would typically use a large language model for. So if you're sitting with a data set of very high-dimensional data, even using the API method to call the large language model directly to analyze your data is perhaps not the ideal. And you could relatively easy using publicly accessible code bases on Kaggle and other platforms, gather the code in Python and create a Python playbook, for example, to spin up an artificial neural network and then to start loading your data into that and analyzing that. Now, this is quite an expansive topic for the other day, and really left to computer scientists or bioinformatics scientists to explain to us. I'm not going into any further detail to that. I just wanted to use this opportunity to describe this in principle, since we do get a number of requests in the library to advise our users what methods should be used for analyzing data sets. So thank you. That's my presentation, and I'm happy to take questions. We've got a number of minutes for questions.
Thank you very much, Wouter. Yes, so any questions anybody might have, you're welcome to unmute yourselves as well, if you have a question. Yes, Prof. Mattia.
Thank you very much, Wouter. It's really a cool presentation, all of it over my head, but the rest I could follow. I went to this AI thing 2 or 3 weeks ago, and we've been informed about using AI, for example, in Excel, which I think is Copilot, to just draw tables and these sort of things. I guess that's fine. We don't need to actually worry about the quality, and if you do it the next day, you get something different, or how does that system work? Will it suffer the same problems than what you've just explained to us?
Yes, sure. So if you've got an Excel sheet and you're uploading that into, was it ChatGPT, for example?
It was in Excel, and I think they said we can use the Copilot function there. There's a little thing there in the top.
Yes, you said Copilot. It would do essentially exactly the same thing I described in a couple of slides back. Yeah. So Copilot also has different document processes built into it. When you're using Copilot, you also not speaking directly to each version of the OpenAI model Copilot uses. It's also pushing your data through code interpreters and then doing the analysis on your data set. So I would imagine that if you were to try and reproduce that processing run in a couple of days from now, you most likely will get different results. I would also imagine that the version of Copilot's OpenAI large language model obviously will be rather closed, and it won't be date stamped like on a very specific day. I could speak under correction on that, but I would think that you will sit with the same scenario, that you will not be able to reproduce exactly that data analysis. I haven't tried it yet.
So can I just clarify? So it means like if we just want to draw a histogram, that's probably fine. But if we want to analyze a complex data set, we should rather not.
Yes, that's very well explained. Thank you.
Thank you.
And then there's a question in the chat. In your example of sentiment analysis, is AI analysis more reliable, in parentheses acceptable, than the researcher's own classification?
Yeah, that's a difficult question. I would imagine that a researcher's own classification would always take preference in terms of reliability. Whether that researcher is using a team of students to classify against a dictionary, or using a simple language model to do a word-to-vec classification, etc. If we're talking here of is AI analysis more reliable, then I would imagine the question is related to if you were to use a large language model to do the classification for you, is that more reliable or not? No, that I wouldn't determine that as more reliable. The most reliable way to use AI to do that sort of sentiment analysis is within a simple language model where you use word-to-vec and word-of-bags techniques, which aren't built on large foundational models and which are optimized for language purposes. And then you have very specific control over how that sentiment analysis is done. So that's a sort of a qualified answer I'm giving here. The answer is yes and no. Yes, for AI could be more reliable if you used a simple language model and using the correct machine learning techniques. But no, AI wouldn't necessarily be more reliable, even if you used an API call to a large language model. Because within the large language model is doing a token prediction once again, and it's not doing your word of bags and your vector analysis of your words, which are more optimized for specific sentiment analysis research. I hope that helps. I'm not an expert on this, but I'm saying this qualified from what I know about simple language models and what I know about large language models and how to call a large language model in an appropriate way for data analysis. Here was a follow-up question from Philip. Can you share the actual inputs and outputs of your free pizza example to give more context to the presentation? Oh yes, well I didn't. I did not prepare those in my presentation, but I can share them for clarity afterwards. I can share them in the chat that at least you can relate what I'm using as an example to how I'm trying to explain what the best way is to use to call your large language model. So what I'll try and do is I'll produce a Python script which does the API call, and then within that you will see the inputs, input prompts and the temperature readings, the max token settings, which you can use to call different observations, to call the large language model to process each single observation within the data set. The data set is freely accessible from Kaggle. Have it in the presentation, we can get it from there. Hopefully that will help.
Thanks, Wouter. And a question from my side. A lot of this is, I think, for plenty of researchers, a very technical approach. The idea of actually manipulating a language model without an interface like a ChatGPT or Gemini or so to assist. Is there any kind of support systems in place at the university who can assist researchers with setting up this kind of data analysis system, or is there at least talk about getting something like this in place?
No. The only support system I can think of is the one Dr. Kim Martin, and I now forgot this software carpentry courses she presents, and it's located within her support service. I just forgot the name of the support service, but Dr. Kim Martin, she presents software carpentry courses to help you write Python scripts, which are of a rather simple nature, which you will be able to use to call an API, for example, in a large language model. This support service is not available from IT because they really look after the network and the operations of our systems, but they don't really provide this research support on a computational basis. So I don't have a clear answer on that. My presentation was focused towards helping yourself generate simplistic code with Claude code. So actually, the support service is to use Claude code as a good preference towards generating some code for you without having the ability to code. Now, I should make it clear, if you're doing a iterative loop, writing a piece of code to do an iterative loop to read every observation within your data set and send it through to an API, that is not very difficult coding to do. So if Claude were to receive your very specific instruction in order to produce a piece of code like that, you wouldn't have to mistrust that in any way. The code will be accurate, and you could just use it like that. I hope this helps in a way, but there's no clear answer to what sort of support service there is at the university. Perhaps, if I could just continue here as a follow-up question. Using a large language model, can you localize the training module to ensure data document security? Not have the model use it elsewhere. So if you were to call your large language model through the API, it will not use the prompts and the prompt data you send it to train itself. So using the method I'm proposing here, your data will not be used for subsequent training of the large language model. However, if you use the chat interface and you uploaded the whole document as one set and you forgot to select the option, they're very scaly these days. They're not really explicitly in the prompt they give you when you upload a document, tell you that your data can be used for training purposes. They sort of hide it behind different words. But if you forgot to tick the option not to use, not to have your data set being used for future training, then obviously you can't localize your training model. However, there's another way. You could use a large language model to analyze your data without an API call, but having your training data secure in a separate database, and that's what we call retrieval augmented generation. then you can in your prompt you can call the data within your own local database and include that and that gets included in your prompt and sent through to the large language model for analysis. In that way, your data is not included in the model for training. I'm not sure if I'm answering this question correctly, though. Okay, there's a thumbs up, so hopefully that was helpful in some way.
Right, so is there any other questions for Wouter? Does not seem like it. So then I'd like to thank you again, Wouter, for this presentation. I think it's the high level of the information given has provided a lot of clarity and guidance for people on how it can be used to an advanced level. And yes, thank you very much, everybody. And we hope to see you at the rest of our sessions that will be taking place today. Goodbye, everybody.
Thank you.